Okay, this is Friday, 4/27. Make sure before you start this that you turn in your homework from the last couple of days. It's 5:13, 5:14, 1 through 9. And on the same paper, you should have 5:14, 10 through 13. Turn that into the sub right now before you start this practice. Okay, have her put it in the folder. Okay, so this review covers all the activities from 34, 35, everything we've done so far with matrices is today. Okay, so this is the key. This is Friday. Make sure you turn this in when you're done. Find x and y to make the matrix equation true. Okay, so this is a 2 by 1, and this is a 2 by 1. Since there's an equal sign, you're just trying to say, what would x have to be to make this equal to this? And what would this y have to be to make these equal? So you have y's and x's. So you're going to set up a system of equations. So you're going to set 2x minus 3 equal to y, and you're going to set 4y equal to 3x. And you're going to do substitution. Since y equals 2x minus 3, you can substitute this into the y of the second equation. So you would have 4 times y, which is really 2x minus 3. We're substituting, equals 3x. Now notice you have an equation now that only has x's. Because the first equation had x and y, the second equation has x, y. This is a system, 2 different equations, but you can substitute or do linear combination, do all kinds of things, but we're going to substitute. So 2x minus 3 into the y right here. Now we're solving for x. So distribute. I'm going to subtract 8x over, get negative 12 equals negative 5x, and x is 12 fifths. Beautiful answer, right? 12 fifths. Now, what's y? So if x is 12 fifths, what is y? So we're going to substitute that back into this. So we're going to have 2 times 12 fifths minus 3 equals y. This is 24 fifths minus 3. I'm going to change 3 to 5. We'll change that to 15 over 5. 3 is really 15 fifths. You can do this on your calculator if you want, but I don't like using calculators for this. I'll change 3 to 15 fifths so that I can subtract it from 24 fifths. So 24 minus 15 is, let me think, is that 9? 9 fifths. So y equals 9 fifths. So our answer is x equals 12 fifths and y equals 9 fifths. Beautiful answers. So should we see if that works? If you on your calculator plug this x in there, let's see. If we plugged in 12 fifths into x, it'd be 2 times 12 fifths minus 3. That's right here. That should equal y, which is 9 fifths. So this should equal 9 fifths. Let's press enter and then press math, enter, enter. 9 fifths. That works. And then this, for 4 times 9 fifths should equal 3 times 12 fifths. So let's see if that works. 4 times 9 fifths. I'm not sure if I need parentheses. Let me do that again. 4 times parentheses 9 fifths is equal to this. And that should equal 3 times 12 fifths. And that's 7.2. So even though they're ugly answers, they're the answers. Hopefully you guys somewhat got that. So on this next one, it says matrix A is this, matrix B, matrix C, and they want us to do all this fun stuff. Let's do it by hand, but you can actually do this on the calculator as well. A is 7/8, 7 and 8, 0, negative 4. Plus B, which is negative 3, negative 5, 2, and negative 2. So if you add these, we're adding this. That's going to be 4. 8 and negative 5 is 3. 0 and 2 is 2. And negative 4, negative 2 is negative 6. That's your first answer. B minus A, so I'm going to write B minus A. And A is 7/8, 0, negative 4. Now when you're subtracting, it's the same thing as changing all the signs. So I'm going to change this subtraction to plus and make all these to their negative, but you don't really have to change 0. Oh my gosh, you guys can't see that. Sorry. So instead of subtracting A, I'm going to add the inverses of all of A's numbers. So it was 7 and 8, now it's negative 7, negative 8. It was negative 4, now it's 4. And now I'm going to add. So that answer is negative 10, negative 13, 2, and 2. So we're adding this one to this one. We're adding this one to this one. We're adding this one to this one and this one to this one. C times B. Okay, you guys can do this on a calculator, but I'm multiplying by hand. So C is 2, negative 5 times B, which is negative 3, negative 5, 2, and negative 2. This one right here is a 2 by 1. This one right here is a 2 by 2. And you're not allowed to multiply them because the 1 and the 2 doesn't match up. Impossible. So what's negative 4 times C? So negative 4 times C means that this is called a scalar multiple. So you're going to multiply both these numbers by negative 4. So your answer is negative 8 and 20. That's your answer. Now for A is 7, 8, 0, negative 4, minus 2 times B. And B is negative 3, negative 5, 2, negative 2. So if we changed all these by multiplying by 4, you'd get 28, 32, 0, negative 16, plus negative 2 times negative 3 is 6. Negative 2 times negative 5 is 10. Negative 2 times 2 is negative 4. And negative 2 times negative 2 is 4. And then we add. So the answer should be 34, 42, negative 4, and negative 12. I really think we should multiply one of these. I know it's not on here. You have to know how to multiply, so let's multiply one of these. You know where it said you couldn't do C and B? Let's do B. Let's do A times B. I can multiply 2 by 2 and a 2 by 2. So let's do A and B because you need to know how to do these. Since they're already written up here, let's do A and B up here. So if you're doing A and B, your answer is still going to be a 2 by 2. Go. Right straight across in 115. So you're going to do row 1 times column 1. So that's 7 times negative 3 is negative 21 plus 16. Negative 21 plus 16 is the first one. Now if you circle the second column with this first one, you're going to get negative 35 and negative 16. So those are grand totals of, this is negative 5, and that would be what, negative 51? So far it's negative 5 and negative 51. And then we're going to circle row 2, so we're done with row 1. So 0 times negative 3 is 0. And negative 4 and 2 is negative 8. So this is going to be negative 8 over there. And then we got, this one's done. So we got 0 again. And negative 4 and negative 2 is 8. So this is positive 8. So this would be your answer if you multiplied A and B. Make sure you know how to multiply. So to find the determinant, you're going to multiply minus this one. Make sure you start with the negative 2. So this is 24, and that is 0. This one is 27 minus negative 35, which makes that plus 35, for a grand total of 62. This one by hand, you need to pick a row or a column. The easiest one, I'm going to pick 2, 3, 1. So you're going to write 2, 3, and 1. Now, there's a sign chart assigned to each one of these. The sign chart of a 3 by 3 looks like this: plus, minus, plus, minus, plus, minus, plus, minus, plus. Since I picked row 1, those are the signs that are attached to it. So this is positive, negative, positive. Those also go out front. Now, each one of these is assigned a 2 by 2 determinant. So for the 2, what you do for the 2 right here is you cross off the row that it's in and the column that it's in. So that what's left over is negative 1, 5 and negative 4, 2. That's the 2 by 2 that's assigned to it. For the 3, you're going to cross off the row that 3's in, and you're going to cross off the column that it's in. So you should have negative 3, 1, 5, 2. And for the 1, you should cross off the column that it's in and the row that it's in, and you would get -3, 1, -1, -4. Then cross multiply to find the determinant. So -2 minus -20 is 18. Times 2 is 36. The middle one, you get -6 minus 5, so, or -3 times -11, which is 33. And then this last one, it's 12 minus -1, which is 13. So you get 70, wait a minute, let's see. This is 69, 79, 82. Looks like 82 is the grand total. Find the inverse of each. In order to find the inverse, you first have to find the determinant. So to find the determinant, you get 20 minus 20. Since the determinant is 0, inverse does not exist. You cannot take the inverse of 0. So let's do the next one. First thing we're going to do is find the determinant. The determinant is 2 minus 0, which is 2. That's the determinant. Now the inverse, you take the reciprocal of this, and then you have to do a little switcheroo. So you're going to switch places with this one. Switch with the first product. So instead of 2 and 1, you're going to have 1 and 2. So it was 2 and 1, now it's 1 and 2. The other diagonal, you're switching signs. It's kind of hard to switch signs of 0. So it's still 0. But if you switch the sign of this -5, you will get a 5. So change signs of the second diagonal. Then you distribute. So 1/2 times 1 is 1/2. 1/2 times 0 is 0. 1/2 times 5 is 5/2. 1/2 times 2 is 1. And that is your inverse. So we're going to go back to number 7 real quick. And just really quick, make sure you know how to do this on the calculator. So you're going to press second matrix. Go over to edit, press enter, and type in a 2 by 2. And it is -2, enter 3, enter 8, enter -12, enter. So you get it in. Then you press second mode. Quit your screen. Now press second matrix. We want to go over to math for determinant. Go over to math. Determinant is the first one. Press determinant. Then press second x -1, 1. So you want the determinant of A. You press enter and it is 0. And that's how you do this one. So if you were going to do that one, you would do second matrix. Go over to edit. It's already a 2 by 2. We're just going to type right over it. It's 3, -5, and 7 and 9. Second mode. Press second x -1. Go over to math. Press enter. Second x -1, 1. It's 62. For the 3 by 3, it's the same thing. Go second x -1, edit. But this time you want a 3 by 3. We're going to type in 2, 3, 1. Really what I'm doing right now is just checking my work. I believe my work is right, but who knows? Maybe I added wrong. I am old, so maybe I didn't see the numbers right because I don't have my glasses on. But there's all kinds of ways I could have missed this problem. I could have typed in a positive instead of a negative. Okay, so I think these are right. 2, 3, 1. I'm double checking. -3, -1, 5, 1, -4, 2. All right. Once that's in, press second mode and press second x -1 over determinant, and we want matrix A again. So I typed right over it. And this answer is 82, and that's what I got there. For inverses, I'm not going to do the first one because when you get a determinant of 0, you can't find an inverse, but I'll do this one. So 11. So second matrix. Let's go ahead and type in over 2 by 2. Oops, that's not what I wanted. Let's try that again. Second matrix, edit, 2. Okay, I just need to clear this out. Second plus 2, 5, delete. All right, let's go back. Now it's out of there. So 2 by 2. And it is a, let's see, 2, 0, negative 5, 1. So what we're going to do is find the inverse of this. So press second matrix. So this time, what I want to do is I'm going to clear my screen. Why is this clear? Okay, clear your screen. Bring up the matrix A. Okay, bring it up. And now to get the inverse, you press this key right here. Press X negative 1, and it'll look like this on your screen. That's A inverse. And then just press enter, and you get this. I just don't like decimals, so math, enter, enter. And you get 1/2, 0, 5/2, and 1. And that's the answer right here. On the back, give the coordinates of the new triangle. Show your matrix. So you have triangle vertices. So to set this up, you're going to go 1, 2, 2, negative 1, negative 2, 0. A scale factor of 3/4 means you put a scale factor out front. And then you multiply everything by 3/4. So you have 3/4. 3/4 times 2 is 6/4, which is reduced to 3/2. So this one's going to be negative 3/2. And then this one's going to be 3/2 again. And then negative 3/4 and 0. Just multiplying by 3/4. Feel free to do that on the calculator if you don't like all this stuff. Use the matrices to determine the coordinates of the vertices of the new figure after the following transformations. Show your matrices, but do not leave your answers in a matrix. So you have a square with vertices right here. You're going to translate 2 to the right, 3 down, and then you're going to rotate it 180 about the origin. So first transformation. So right now we have W, X, Y, Z. We're going to set this up as a matrix, which is your X and Y coordinate. So you're going to go 1, negative 3. I can't even read this. What's that say? 1, negative 3. That's X. There's a lot of things going on here. I think this is supposed to be a parenthesis. This 9 is supposed to be a parenthesis. I'm like, what is this? This is supposed to be negative 4, negative 2, negative 3, 3, 2, 2. So set up your order pairs. Now what you're going to do is you're going to translate this 2 to the right. So when you translate something 2 to the right, you add 2 to everything in the X. And then you're going to go 3 down. To go 3 down, we're going to subtract 3 from all the Y coordinates. And this is how we do it. So that means that W prime, X prime, Y prime, and Z prime will have new order pairs. The new order pairs are 1 plus 2 is 3. Negative 4 plus 2 is negative 2. Negative 3 plus 2 is negative 1. 2 plus 2 is 4. So I got these numbers by adding 2 to the first row. Add 2 to all of those to get the new X coordinates. Now to get the new Y coordinates, we're going to subtract 3 from all of these. So negative 3 minus 3 is negative 6. Negative 2 minus 3 is negative 5. 3 minus 3 is 0. And 2 minus 3 is negative 1. Now what we're going to do is I'm going to rewrite those. 3, negative 6, negative 2, negative 5, negative 1, 0, 4, negative 1. So this is currently W prime, X prime, Y prime, and Z prime. What we're going to do now is we are going to rotate this 180 around the origin. 180. So it doesn't matter if it's counterclockwise or clockwise if it's 180, because you're still at the same spot. So what does it mean to move something 180? Okay, it moves like semicircle. So if you look at your notes, 180 is right here. A negative 1 in the top means that you're changing all the X's to their opposites. A negative 1 in this position means you're changing all the Y's to their opposite. So you could just do that without doing any fancy work. However, we're going to put that out front. You always put your rotation out front because this is a 2 by 3. And we're going to be multiplying by a 2 by 2. So 2 by 2, 2 by 3, the 2's have to match up. 2 by 2, 2 by 3. Like you would not be able to put this behind it because the 3 wouldn't match up with the 2. It has to go, the rotation has to go out front. So if you're multiplying, you could multiply this on your calculator. Enter this, and multiply them on your calculator to get your new answers. You could also know that a -1 in this position just changes all these to their opposite. A -1 in this position means you just change all these to their opposite. But I'm actually going to show you the multiplication. So in row 1 times this. So -1 times 3 is -3 plus 0. So that's -3. Second row. -1 times -2 is 2 plus 0. Third row. -1 times 1 is 1 plus 0. And then the fourth column, -1 times 4 is -4 plus 0 is -4. Do you see how I just switched all the x-coordinates to their opposites? Just make sure that they're still there. And then the -1 in this spot just means you're going to switch all the y's. So that means I would circle the second row here. So it's the second row times the first row. So this would be 0 plus 6. Second column. 0, 5. 0, 0. 4, I'm sorry, that's 0. 0 times 4 is 0. And 1. Notice all the y coordinates just switch to their opposites. And this is called W2 prime. I'm not sure. W2, W prime 2. I'm not sure how to say that. I'm not a geometry expert. Y prime 2. I'm probably saying that wrong. And Z prime 2. So this is your last graph. Now for fun, wouldn't you like to see what this would look like if I graphed it? I know you guys are like, can we just finish this graph? But let me just see. The first order pair given was 1, -3. That's W. And then the next one was -4, -2. That's X. Y was -3 and 3. That's Y. And Z is 2, 2. You get Z. So what does it look like when we translated 2 right and 3 down? So if you translated 2 right and 3 down, I'm going to use my answer here. That would have looked like this. 3 negative, maybe we should do it all on the same graph. Let's do it on the same graph. Maybe I'll make it more fun. 3, -6 would be down here. That would be W prime. -2, -5. That is called X prime. Y would be -1, 0. Y prime. And Z was 4, -1. So it should have the same shape. And that kind of tells you that you were probably doing it right because it has the same shape. But we moved everything 2 right and 3 down. Makes sense, right? Oh my God, you can't see my picture. So sorry. So the blue one was the original. The blue one's the original. The red one is the first, is our translation. 2 right, 3 down. It looks like the red one went 2 right and 3 down from the blue one. Still can't see it. Oh my gosh, you guys, I know you're thinking I'm crazy. Blue one's the original. Red one's the prime, first prime. Now the last answer was -3, 6. What does that look like if you rotate something 180? It's like taking a dice and just rolling it so that it rolls over 180 degrees. So that turns into this. -3, 6. This is where our W prime 2 is going to be. It was here. Here's W originally. Then this was our new one. And then you rotate this 180 degrees. So if you have a line right here, you rotate this 180 degrees, it goes straight across. 180 degrees means you go straight across if you had this X, Y axis. 2, 5 is X prime 2. Notice where X is. See how it's straight across? And then Y was 1, 0. Notice how this is straight across. And -4, 1. I kind of like doing this just so I can see if my shape is still the same. So from the red to the green, The red, when you rotate the red 180 degrees, it'll be where the green is. I thought that was a great drawing. Don't you guys think? If only you could have seen the first part of that. All right, quadrilateral. We are going to write this down. P is -2, 3. H is 3, 4. S is 3, -1. And N is -3, -4. Pickerington High School North. Woo! We're going to rotate this 90 degrees. Now, does it say clockwise, counterclockwise? No. So let's say it is counterclockwise, so that we're going to use the one on our paper. So we're going to rotate 90 right here. This means, this one right here, it means that if you have a 1 in this spot, it means all the x-coordinates are going to be in the bottom row, and they're going to be their opposites. So when it's in this spot, it means all the x-coordinates are going to the bottom, and they're all going to change to their opposite. When a 1 is in this spot, it means the y-coordinates are going to the top row, but they're staying the same because it's positive. So if you can get that, you don't really have to show any work. If you don't get that, use your calculator and multiply these. So put it out front. This is rotate 90. Put it out front. They really should say rotate 90. Like, I think of everything that they give me as counterclockwise because that's the positive angle. So if they want it to be clockwise, they really should say the angle that it would be if it was counterclockwise. So I'm going to take all rotations as counterclockwise. All right, what's the answer to this? So we're going to find P prime, H prime, S prime, and N prime. If you're doing the first row here in this, just to show you what I was saying was right, this is 0 and this is -3. Maybe I was wrong. Oh, I said the y's go to the top. Oh, the y's are switching. I was wrong because the y's are switching to the top and they're becoming the opposite. So I guess the -1 in this spot is the y. Okay, it is in the y spot, right? It's in that second row. This is the y's. You're bringing the y's to the top and you're switching them to their opposite because it's in the top row. I'm sorry, I was wrong when I said that. All right, 0 and -4. So it looks like we're bringing all the y coordinates to the top as their opposite. So let's just continue that. Instead of -1 on the bottom, it's going to be a +1 on the top. Instead of a -4 on the bottom, you're going to have a +4 on the top. So the bottom row is now the top row, all in their opposite form, which means the x's. So this is in the x spot. It means the x's are coming to this rope and they're saying they're the same. If you're not sure about that, 1 times -2 is -2 and 0. So the x is not going to change. So we're bringing all the x's to the bottom row like that. Then they want us to do this, y equals x. What does that mean? It means switch the y's and x's. It means you're going to reflect it over the origin or the line y equals x. So on our notes, let's look at this. Here's our notes, y equals x. It just means switch x and y. See that? Inverse means switch x and y. If you want to actually multiply with that, you would write 0, 1, 1, 0 times this. If you're doing this on your calculator, that's what you would do. And your final answer is going to be P2, H2 prime, S prime 2, and N prime 2. So your final answer, basically, we are just switching the x and y. That's what this means. And that there's no changes because they're positive. If you were actually trying to multiply, this would be 0 and -2. So the -2 goes here. So we're going to we're switching the y's back up to the x row. And we're putting the x's in the y row. If you don't get that, punch this in the calculator and you will get this. Find the area of the triangles with vertices right here. -1, 4. We'll call this A. Let's go ahead and get that set up right there. Our second one, we'll call it B, is -5, 6. 3, 4, 5, 6. And C is negative 3, 2. So we have this triangle. And that's how you write it as a matrix. What we need to do before we can find the area is we need to move one of these 3 vertices to the origin. Because we need one of these to be 0, 0. So which one do we want to move? The A, the B, or the C? Sometimes people just like moving A because it's A. Some people like moving C because it's kind of closest to it. But let's just move A. If I wanted to move this point to 0, 0, what would you have to do? I would need to make negative 1 turn to 0, and I would need to change 4 to 0. So in order to change negative 1 to 0, I have to add 1. But if I add 1 to the first one, I have to add 1 to the whole row. How do you change a 4 to a 0? You subtract 4. Subtract 4, subtract 4, subtract 4. In other words, you're going to come down 4. But you have to do that to all of them. So my new ordered pairs would be negative 1 plus 1 is 0. Negative 5 plus 1 is negative 4. Negative 3 plus 1 is negative 2. 4 minus 4 is 0. 6 minus 4 is 2. 2 minus 4 is negative 2. So our new triangle is 0, 0, which is going to be A prime. It's going to be negative 4, 2. It's going to be B prime. And negative 2, negative 2, which is C double prime, or C prime, which looks like this. It should still have the same shape as the first one. We just moved it. You see how we moved everything down? We just moved it down. So to find the area of this triangle, we're going to go 1/2 of the determinant of the 2 ordered pairs that aren't 0, 0. So that would be negative 4, 2 and negative 2, negative 2. So if you cross multiply, you get 1/2 times 8 minus negative 4, which ends up being 8 plus 4, or 12. So it looks like 6 units squared is the area. 6 units squared. That's your answer.